All right, let's talk about the problem of resource management for a second. Very common problem in a lot of applications is a situation where you might use like a resource, like a file or a socket or a database or something like that. You use it for a while, and then you have to release the resource. For example, you open up a file, and then you read from the file, and then you close the file. This is an example of using a resource. It's like you open it, you use it, you release it. You actually see this in a lot of different places in Python. For example, if you decide to get into something like thread programming, you might do something like make a lock object, and then what you'll do is you'll acquire a lock, use the lock for a while, and then when you're done with it, release the lock. So this pattern of open something, use it, close it, acquire something, use it, release it. Turns out that this programming pattern that you're seeing here is very problematic in practice because it is easy to forget the cleanup step. Like it's easy to forget the close step. It's also possible that you can get weird errors that take place. For example, let's say you acquired a lock and then somebody did like a bad calculation. I don't know, they did like a bad int conversion and the program bailed out with an exception. You get into all these questions about, well, like what happened to the lock? Is it cleaned up? I mean, what happened there? A common solution to these problems is to see code that makes use of the with statement. Like you might see code where it's like, okay, with open CSV, for instance, as F, and then you use the file. Or you might see an example where somebody will make a lock and they'll say with lock, use the lock like that. This with statement is a way of enclosing a block of statements where you're using some kind of resource. It turns out to be so useful that I think it's worth knowing how this actually works under the covers, because it might be something that you want to put into your own code in some way. So the thing that we're looking at here is something known as a context manager. What drives that with statement is a pair of special methods called enter and exit. You can make a class that has an enter method. I'm going to put a print statement in here, and I'm going to have it return some value that I'll describe in a second. And then you can have an exit method. I'll print exiting here. And I'll describe these arguments as well in a second here. But what you can do is make a class that has those methods on there. You can have other methods on there too. These just have to be there. And if you do that, you'll find that the objects that you make can work with the with statement. Let me import that and let's make a manager object. So I'm going to make a manager. If I have that, I can now do things like with M, and then I can enclose statements. What you're going to see is this code that you've written is being bracketed by the entering method and the exit method. So you see it come up printing entering, you see the hello world, you see the exiting. If you were to have multiple statements in there, like hello world, and then maybe a for loop or something, you would see all of that code actually run in between the enter and the exit method. So it's a way of capturing when that block of statements is executing. The key idea is that the exit method, well, actually both methods, could take some kind of action. Like perhaps like the exit method would do a cleanup, releasing a lock or deleting a file or doing some kind of, cleanup of the environment. Now, a few little odds and ends about these methods. The enter method, as you will notice, has a return statement on it. That is actually what is driving this little as qualifier. Like you can say with M as val, for instance. And that val is actually the return from that enter method. If I did with M as val and printed it out, you would actually see that getting that value that came back. So the enter method can elect to return kind of anything that you want, and you can pick it up in a variable as I've shown there. The exit method also has some options to deal with exception handling. It turns out that these three arguments that go into the exit have to do with whether or not there's a pending exception that has taken place. For example, if I say with M, let's say I said, print hello world, and then let's say some kind of bad calculation took place here. One of the things that you're going to see is that the enter method will fire, get the hello world, but then the code is exiting, and you will actually see that there is a pending exception sitting there. It says, oh, well, there's a value error that has been raised. It'll show you the message, and it gives you a stack trace and so forth. This is actually giving the manager the option to act on that error. For example, let's say you were doing like a transaction on a database or something. if there was an error that took place, maybe the exit could elect to abort the transaction. You could say, well, if there's an error, I'm just not going to commit whatever changes took place. This is actually kind of a neat thing to know about, that you can override enter and exit. It can be especially useful in programs that have to deal with resource management. Opening, closing files, acquiring, releasing locks, subscribing and unsubscribing from feeds, things of that nature. And this is how you program into that.